WA2 revision event. We'll be focusing on electrochem. But before that, let me just do a quick introduction to OVERMUGGED. So I think most of you know here are from OVERMUGGED itself. Currently, we have 7 branches across Singapore. On average, 70% of our students achieve distinction at national exams. Maybe what I'll do is I'll do a brief introduction to myself first. So I'm Ashley. Just address me by my name, it's fine. I teach chemistry and maths here at OVERMUGGED, primarily at the JC level. So most of my classes are JC chemistry or JC maths classes, but I do have a pure chem class at Bishan. So on average, I'm currently teaching about 70 students per cohort, and usually most of them are from J2s. So previously I was with NTU. After that, I graduated and I became a textbook editor at Marshall Cavendish Education. So I think all of you are using your chemistry matters and physics matters. Actually, that was my last project at Marshall before I left to do full-time teaching. Okay, so that's just a brief introduction to myself. Any one of you, if later you need to address me, just address me by my name lah, okay? Don't need to call me sir or mister or teacher. Very weird. Okay, anyway, so today's agenda, what are we going to do? I'll be doing a content summary on electrochemistry first. After that, what I'll do is I will go through some important questions that may come out for your WA2. Okay, now this is the last call for the materials. Oh, wait. QR code is wrong. Okay, so if you have not obtained the materials itself, please scan this QR code for the materials. What happened is, alternatively, I'm going to be putting up the Zoom link into the Zoom chat so that anyone who comes later can get the materials. So just give me a minute. Let me grab the link itself. Okay, then you guys can just get ready lah. Put your notes inside the iPad or whatsoever not. Okay. Try this. Okay, give me a minute. Okay, so yeah. Okay, if you can't access the QR code, here is the Google Drive link itself. I'm putting it inside the Zoom chat, okay, for everyone. Okay, if not, then I will not waste your time. Let's get this class started. Yeah. Okay, so I think most of you here are here for electrochemistry. What I will do is this. I think most teachers teach electrochemistry by just giving you a lot of examples. But my way of teaching electrochem is I prefer to give you a set of thinking. So let's take a look at what to expect for electrochem itself. I think most of you should be receiving this set of notes inside that drive itself. Okay, so when it comes to electrochem, take note, number one, what you need to think of is this. 2 things. Number one, focus a lot on the chemical reactions that will happen at the cathode and the anode. Okay, so the first thing you want to think of is, number one, the chemical reactions that tend to happen at the cathode and anode. Next, number 2. So the idea of how to choose what ions to get discharged and what they turn into, that's what you're thinking of when it comes to chemical reactions. Number 2, also take note, most teachers like to ask you for observations. And if there was a gas that was being formed, then what they might also ask you is also the test itself, okay? So you need to know your observations plus tests that is happening at both the cathode, the anode, and the electrolyte. So generally, these are the exam questions that will come up for exams. Okay. Now, how do we go about doing? So there are two types of cells that you will be tested on. One is called an electrolytic cell, and one is called electric cell. Okay, which is in part 2. So what is an electrolytic cell? Electrolytic cell is basically, you think of it this way: use electricity to initiate chemical reactions. So the chemical reactions that you will come across is primarily 3 of them: electrolysis, electroplating, and electrolytic purification. Okay, now how do we go about doing electrolytic cell? So basically what we need to do is, step 1, we need to dissect the diagram. So you will often be given a diagram to dissect. Okay, so how do you dissect the diagram? Very simple. Just remember, the long side of the battery is called the positive terminal. So the long side of the battery is the positive terminal. Basically, the electrode that's attached to it will also be positively charged. So you must remember, long side of the battery, positive terminal, the electrode that's attached to it, positively charged. So a positive electrode will tend to end up attracting anions, and anions themselves are negative ions. So if you think about it, from a business sense of point, is that if today you open up a shop and you want to attract anions to come to your shop, obviously you want to name your shop such that the anions can identify them. So that is often why we call it the anode. See, so that anions know that they should go to the anode. Next, in electrochem, you must always remember this, the rule called anox. So what is anox? That means anode undergo oxidation. But besides knowing that, so remember, your anode undergo oxidation, you must then link it up to redox reaction. So based on what we learned in redox reaction, oxidation means that they will lose electrons. So what does losing electron means? That means the reaction will lose the electron out. The electron will then be produced out. And then the electron will then flow over to the cathode itself. Next, the short side of the battery is the negative terminal. So the electrode that's attached to the short side will be negatively charged. So in this case here, using the same logic, you have a negative electrode, you want to attract anions, cations, which are positively charged. So more often than not, that's why we call it the cathode. And then from there, the second idea, red cap, which means cathode tends to undergo reduction. So that's why reduction happens. And in reduction, basically what happens is electrons are being gained. So the key idea is, take note, a common similarity between electrolytic cell and electric cell is that your electrons always flow from the anode to the cathode. So you must remember, electrons always flow from anode to cathode. Okay, now after you dissect the diagram, then part 2 would be to think of this framework. Okay, so this is how I would remember how to derive out the products that's happening at the cathode and the anode for different situations. Okay, so primarily in the framework, you ask yourself 3 questions. What are the 3 questions? Question number 1, or the first question you should ask yourself is this: are the electrodes inert or reactive? Now, what is the meaning of inert electrodes? Please remember, inert electrodes means they are unreactive, so they do not react. Or in a way, what you can think of is they do not participate. They will not interfere, they will not participate in any of the reactions in electrochemistry. Whereas a reactive electrode would tend to react, they will tend to participate. Now, this idea is quite important, is because it's one of the common misconceptions around. People always don't really understand what inert means. Okay, so if you ask yourself the first question, are the electrodes inert or reactive? Obviously, you have two answers: inert electrodes and reactive electrodes. We'll talk about reactive electrodes in a minute. Let's just focus on the inert electrodes. So if you have inert electrodes, then basically your focus should not be on the electrode, it should be on the electrolyte. So the second question you ask yourself is the electrolyte molten or aqueous? Now, what is the meaning of molten? Molten means no water. Aqueous means obviously there's water present. Okay, now let's look at molten. So if your answer is a molten electrolyte, then it's very simple. You only have one set of ions to deal with. So just need to focus on that one set of ion. You look at your salt, split the salt up. There's Na plus, there's Cl minus. So basically the idea is send the cation ion to the cathode, send the anion to the anode. The key idea, very simple. Just remember, metal ion always will become a pure metal. Non-metal ions in general will tend to become the non-metal, the pure non-metal itself. So that is what you see in your molten electrolyte. Will molten electrolyte likely come out for your WA2? Unlikely. What you want to put more focus on is on aqueous electrolyte. So if you have an aqueous electrolyte, then that is where you ask yourself the third question. Is the aqueous electrolyte dilute or concentrated? So if you have a dilute electrolyte, take note, very easy. Step one, split the salt up. So you will have a salt itself, you will also have water. So what you need to do is, you need to consider splitting the salt up and splitting the water up. Okay, give me a minute. Okay, so your salt, you split it up, Na plus, Cl minus. So that is your salt. Then for water itself, you also split it up into H plus and OH minus. Now, for those of you who are from IP, you do not split the water up. So what you do is you put water at cathode and water at anode. So same thing, what you do is send the cations to the cathode, send the anions to the anode. Okay, for the cathode itself, so the issue with aqueous electrolyte is you have two sets of ions. You need to choose who to go out first, who to get discharged out first. So in this case here, take note, how do we make that choice? That is what this lesson should be all about lah. Okay, at least that should be what you should remember. So in a sense, what happened is when I have a dilute aqueous electrolyte, I work out the salt to be Na plus and Cl minus. I work out the water to be H plus and OH minus. I have two cations. I send them both to the cathode. So Na plus and H plus. For my IP students, you have to think of water instead of H plus. From there, what you do is you make your choice based on the reactivity series. The lower, the better. The lower, the more likely it will go out. So what happened is, if you recall the reactivity series, which is why for those of you who are not tested on reactivity series but tested on electrochem, you still need to remember your reactivity series, which is potassium, sodium, calcium, magnesium, aluminium. Because pop singers can make all crazy zombies in town lose his cool silly goose, or at least that's how I remember it. So pop singers can make all crazy zombies in town lose his cool silly goose. Okay, for IP students, remember, water will be placed between zinc and iron. For RGS, if I'm not wrong, your teacher put water as a replacement of hydrogen. But if I'm wrong, do sound off, okay? So basically, very simple. When you have your cathode or you have your cations at your cathode, who to get discharged? Just think of reactivity series. The lower, the better. So the lower the ion, the more likely the ion will be discharged. Okay? So then from there, just remember just now what I told you. Metal become pure metal, non-metal become pure non-metal. So if you can see, the H plus is lower in the position, so the H plus will get discharged to form a non-metal H2 gas. Next, for N ions, okay, so I have Cl minus and I have OH minus, and obviously I will send them to the anode. Now, I think a lot of you, what happened is when it comes to N ions, then obviously your overmarked tutor or maybe your teacher will tell you that you need to memorize the electrochemical series, which is SO42 minus, NO3 minus, Cl minus, Br minus, I minus, or OH minus. But I am going to tell you, don't need to memorize that. Why? Number one, if you have an aqueous electrolyte, to be honest with you, O levels have never tested a solvent that is not water. So almost 99.9%, I want to say 100 lah, but I give myself a little bit room of error. But what happened is 99.9%, the solvent is always water. If you have water, you have OH minus. And if you have OH minus and you look at the series itself, OH minus is always at the bottom. So what happened is, in this case here, please take note, it's the same idea. You choose the one that is lowest in the series, but because your solvent is always water and there's always OH minus, so what I ask my students to do is, you just remember, always choose OH. Because OH will always be there. Now, the key thing that you need to memorize more is the equation. So the equation is not the easiest to derive. I would rather you go and memorize this equation. Okay? So basically that is dilute. Now, let's move over to concentrated. So for concentrated, same thing. You will have your Na plus. So your salt, you always split it up into the cation and the anion. Okay? And then for water, you split it up to H plus and OH minus. Same thing, send the Na plus and the H plus, your cations, to the cathode. But what I'm going to tell you here is this. Concentrated electrolyte always will affect anions or anode. It doesn't affect the cathode. So in fact, what will happen is the reaction at the cathode remains the same. So what do I mean by remain the same? That means you think of it this way. The lower the position in the reactivity series, the more likely you will get discharged. Nothing changes. So it's still based on reactivity series, whereby the lower the ion, the more likely the ion will get discharged at the cathode. However, for N ion itself, that is where the problem comes in. So for N ion, what happened is I send my Cl and my OH minus over. But what I want to tell you here is this. So number one, a concentrated electrolyte will only affect anions and the anode reaction. But does it affect all anode reactions? The answer is no. So please take note, the concentrated effect, I call it the concentrated effect, but you think of it as this. If you have a concentrated electrolyte, it will only affect two specific groups of ions, Cl minus, Br minus, and I minus, VSOH minus. So it will only affect these two groups of ions, whereby instead of choosing OH, you choose Cl, Br, and I. Understand? So which means that if let's say today you use a concentrated electrolyte that consists of SO4, 2 minus, and OH minus, take note, still choose OH minus. If you have NO3 minus versus OH minus, still choose OH minus. The only time you need to choose it differently if it's Cl, Br, and I versus OH. then you choose Cl, Br, and I. Then the reaction is still the same. 3 of them will get discharged to form the non-metal. Okay, so I think up to this point, it is a good time for us to put things into practice. So can I get all of you to look at the structured questions, the first question itself? Okay, so can we take a look at question number 7? I'm going to run through this question with everyone. Okay, what I'm going to do is I'm going to give you 5 minutes. Take a look at this question. Try and attempt this question right now. Anyway, anyone with any problems, please feel free to just sound off in the group chat, okay? If you think that I'm going a little bit too fast, please do tell me. I'll slow down. Okay, so I'll go through this in 2 minutes time, 7:55. In the meantime, can you just take a look and then try the question out? Okay, come, let's try out this question now. So, question number 7. The figure shows an electrolysis experiment in which aqueous potassium hydroxide is electrolyzed using graphite electrodes. Okay, so every time you have an electrolysis, so fast. Oh, sure. Okay, I will pause a little bit more. You can try it out. Okay, so the figure shows an electrolysis experiment in which aqueous potassium hydroxide is electrolyzed using graphite electrodes. Okay, I give you all about 1-2 minutes more lah, huh? Okay, so before we embark on the question itself, what I would advise you to do is you dissect the diagram, okay? Get everything out first, including the framework. So number 1, if you see the battery itself, it has the long side. So remember, long side of the battery, positive, okay? So the electrode that is attached to the long side of the battery, the positive terminal, will also become positively charged. So next, your logic thinking is this. You have positive electrode, it will attract N ions, or it will attract negative ions. So negative ions are called your N ions. So therefore, what happens is, you will call this the anode. Okay, so remember, positive electrode attract N ions. So therefore, we should call it the anode. Next, anode will undergo oxidation because anox. So take note, anode oxidation. When you're dealing with oxidation, based on what you remember in redox, it will lose electrons. So losing electrons means the electron will come out from the anode and go over to the cathode. So the short side of the battery, it's the negative terminal, which means that the electrode that's attached to it will be negatively charged. So negative means that I will attract cations. Positive ions, okay? which are called my cation ions. Now, in the event that some of you still cannot remember that positive ions are cation ions and negative ions are anions, very simple, just remember this. Positive ion, you think of pore, positive. So who has a pore? Cat ions, cat. So that's how I remember. So remember, positive, okay? So the positive ions, the cation ions, will be attracted. So to attract them, we will call it the cathode so that the cation ions know where to go. Okay, then remember, red cat, so reduction. Okay, so reduction is also where electrons are being gained. So that's why you need to send the electrons over to the cathode. Okay, so step 1, I dissect the diagram already. Step 2, I will start to use the framework. So remember my 3 questions just now. Question number 1, is the electrodes inert or reactive? So remember, there are only 2 materials that is inert, platinum and graphite. So in this case here, if you can see here, graphite electrode. Okay, so that means I have inert electrodes. Second question, ask yourself, is the electrolyte molten or aqueous? Okay, obviously the question, if you can see here, is aqueous electrolyte. So the last question is to then ask yourself, so question 1, question 2, and then question 3, ask yourself, is the aqueous electrolyte dilute or concentrated? So they never mention anything means that you can assume that it will be dilute. If it's concentrated, usually they will tell you that. So if it's dilute electrolyte, everything is normal. There's no weird things happening. So how to do? Very simple. You take your salt, you split it up. K plus, OH minus. Then take water and split it up. H plus, OH minus. Then what you do is send the cation ions over to the cathode. So at the cathode side, I have K plus, I have H plus. Then between the two, I need to decide who to discharge out. So remember, the lower, the better. So in your reactivity series, hydrogen is lower, hydrogen will come out. Then remember, non-metal ion become non-metal. So in this case here, H2 become, H plus become H2 gas. Then I have 2H, so balance 2. Then I need to balance the charges, so I add 2 electrons here. Why? Because the 2H plus here will give me a charge of plus 2. The H2 gas have no charge. So remember, I need to bring down charges, so I add 2 electrons here, so that the charges are balanced. Next, send the OH minus over to the anode. So basically, I only have OH minus present. So I don't have to make a choice. But what I need to do is I need to remember my equation. So my equation, if I memorize it, will be 4OH minus, giving you O2 gas plus 2H2O water plus 4 electrons. So I've done my whole dissection, and then basically, if you look, the exam questions are likely what I have dissected. Okay, so first one, write the ionic half equation with state symbol for the reaction occurring at each electrode. So A, you tell them, at the cathode, 2H plus. Now, the thing is this, if you see the word ionic, it's expected that you need to give them state symbols. So if your teacher never said with state symbols, you still must give. But chemical equation is like this. They never say don't need to write, okay? But ionic is, regardless of whether they got mentioned or not, you must always write the state symbol. So in this case here, cathode 2H plus aqueous plus 2 electrons, giving me H2 gas. Okay, next, anode. So for the anode side, what I see is this, 4OH minus aqueous, giving me O2 gas plus 2H2O liquid plus 4 electrons. Okay, so that's for part A. Okay, now part B, put a star because part B actually got some answering technique that you need to know. Okay, part B, explain why the volume of the gas collected at the cathode is twice the volume of the gas collected at the anode. Okay, so take note that this one got some answering technique that you need to watch out for. So obviously, I think most of you, your whole idea here will be mole ratio equals to volume ratio. Okay, so if you have done your TYS diligently, you should see this type of question before, whereby they will ask you to think of mole ratio equals to volume ratio. Okay, first thing is, why is the mole ratio 2:1? Okay, so this is where we need to try and combine the two equations together. So how do we combine equations together? Is that the number of electrons must be the same. So we must ensure that the electrons here are the same. Okay, so how to ensure that the electrons are the same? This one times 2, this one times 1. Okay, now how you balance this type of half equation is, you think of it this way. Number one, ensure that the electrons are the same first. So you need to ensure that the electrons in the cathode reaction and the electrons involved in the anode reaction are the same. So that's why I times 2 here, I times 1. Next, put all the reactants on the same side and the products on the other side. Yes, Ray. Oh, okay, sure. I'll slow down. Sorry. Okay, so what I'll do is I will try and combine the two equations together. So to combine the two equations together, what I do is I must ensure that my number of electrons are the same. Okay, so to do that, what I'll do is cathode equation times 2, anode equation times 1. Then from there, what I'll do is usually I will put all the reactants on the same side and all the products on the same side. So what do I mean? For example, from the cathode, if I times 2, I will have 4H plus equals plus 4 electrons. Then for my second equation, my anode equation, because I times 1, so 4OH minus. Okay, next, on the other side, for A answer, must we balance half equation for the final answer? It's balanced already. Why do you need to balance again? So it's already considered as balance. Yes lah, but you need to balance lah. Yeah. Like the electrons. You mean putting, that means both the electrons is 4, is it? Is that what you're saying? No, you don't have to do that. So take note, if I ask you to write half equations for the reaction happen at each electrode, you just balance it individually. But you don't have to ensure that this number here and this number here tally. Don't have to. You only ensure that they are the same when you're trying to come up with the overall equation. So what I'm doing right now is I'm trying to come up with the overall equation. ZH can, right? Huh? Sorry. Do we only need to balance for full ionic? No, in this case here, take note, the question is asking you the ionic half equation at each electrode. So that means the cathode, the half equation, and the anode, the half equation. So individually, you need to balance. But you don't have to ensure that the number of electrons are the same. Rachel, okay, right? But when you are trying to combine the two of them together, then the number of electrons must stay the same lah. Okay, wait, I am not clear about the wait, Oh, okay, sure. I'll slow down a little bit. Okay, so yeah. So what we'll do is we'll balance it. So on the right hand side, 2H2 gas. I think what if you Marilyn, if you don't mind, maybe you stay back after this session. I'll just go through the page again. Oh, yes. So take note, whatever that's written in black right now is the answer to part A. So you don't have to ensure that the ions are the same. So unless I'm telling you to do the overall equation. So when you do the overall equation, then you need to balance both the equations by ensuring that the number of moles of electrons are the same. Okay, everyone is clear about this? Yeah, correct, no problem. Yes, you need to write the overall equation in part B. I'll explain to you why. Give me a minute. Okay, so I need the overall equation for part B because if not, it doesn't make sense. Okay, I will show you why. So next, the right hand side of the equation, 2H2 gas, O2 gas, and 2H2O liquid together with the 4 electrons. So what happened is the 4 electrons will get cancelled out. Then what I need to do is I need to start to combine everything together. So this is the part whereby I will tell you, okay, this part, do I combine it into water? Yes. Because you must remember just now when we tried to dissect the diagram, H plus and OH minus both came from water. So which means that you need to combine them back. So I will have 4 moles of water here, giving me 2H2 gas, a O2 gas, and 2H2O liquid. Then from there, I'll cancel out both sides. And so my final equation will look something like this. 2H2O liquid giving you 2H2 gas plus O2 gas. So if you can see here, you need this equation. Why? Because it helps you to establish that the mole ratio between H2 and O2 is 2:1. Understand? Okay, so what is the answering technique for this? So you cannot just tell me, oh, 2 moles of H2 gas and 1 mole of O2 gas is produced. Since mole ratio equals to volume ratio, so therefore the volume ratio should be 2:1. No. What you need to do is you need to tell your examiner, how did you even come up with this? So what is the link here? So if you think about it, the link was because the number of moles of electron that got transferred is the same. So the answering technique is, this part is very important. So you need to tell them that for every 4 moles of electron transferred, what you get is, for every 4 moles of electron transferred, 2 moles of H2 gas and 1 mole of O2 gas are produced or are formed. Okay, so number 1, establish to me what is the mole ratio. And why is the mole ratio this way? Because if we can see here, in order for us to combine these two equations, the 4 electrons need to be there. Then from there, tell me, since mole ratio equals to volume ratio, so what happened is the volume ratio of H2 to O2 gas is 2:1. Okay, so that's why the volume is 2 times. Do you see? The H2 gas collected at the cathode is twice the volume of the O2 gas collected at the anode. So to answer, I think it's Aisha, is it? Yeah, so to answer Aisha's question is yes, you do need the equation for part 2 to establish the mole ratio so that you can then show that the volume ratio is the same. So that is part 2. So part 2, what I need you to take note of is the answering technique here that I highlight in yellow. Because what happens is, often than not, students will just tell me 2 moles of H2 gas and 1 mole of O2 gas is formed. But take note, your teacher will want you to tell them why the 2 moles of H2 gas and 1 mole of O2 gas is formed. It's because there was 4 moles of electron transferred between the cathode and the anode. So that's why. Okay, so that is part B here. Okay, next, let's talk about part C. So the gas collected at the anode is more soluble in water than the gas collected at the cathode. So the idea is, take note, the oxygen gas collected at the anode is more soluble in water than the H2 gas collected at the cathode. Now, explain how and why the difference in solubility affects the theoretical ratio of the volumes collected. Okay, so basically based on what we know, so part C here, based on what we know here, anode is to cathode the gas, meaning O2 gas is to H2 gas. The ratio based on what we know is 1:2. Correct? Because H2 gas to O2 gas is 2:1 lah. So 1:2. Okay? This is the theoretical ratio. So this is theoretical in theory. However, they are telling you that oxygen gas is actually soluble in water. So which means that it will dissolve in water. If it dissolves in water, that means the volume you collected will be less. So you must understand this. O2 dissolves in water. So the volume of O2 collected smaller. Okay, so let's say the volume that you collect ended up becoming 0.8 and then the H2 is still 2. Now, how is this a different ratio from 1:2? So basically what happened is we will need to recalibrate this into 1:something. So to do that is I'll divide by 0.8 and I'll divide here by 0.8. So I end up having a ratio of 1:2.5. Okay, so take note, this is just an example lah. So this 0.8 here is just an arbitrary value. But why I need to show you this is because you need to compare the theoretical value and the actual value that you calculate. Why? Because the question says, explain how. So you cannot just tell your examiner, oh, the ratio is different. They want you to tell them, how is it different? Is it higher or is it lower? So in this case here, take note, your H2 gas ended up becoming higher. So what you will tell me is, the answer will be this. The volume ratio of H2 gas to O2 gas is, don't need to give me the actual value because 1:2.5 is just a calculation that I'm showing you. Okay, you just tell them is higher than 2:1. Can already. Okay, and why is that so? So it's the whole explanation like what I said just now. As oxygen gas is more soluble than H2 gas, what happened is some of the original gas dissolve in water. So what happened is the volume that the volume of oxygen gas collected will be smaller than expected. But that will cause the ratio to become higher. Okay. Okay, so that is for part C. Okay, I'll pause here a little bit. Anyone have any questions or any problems, any parts they don't understand? Feel free to sound off. So far, everyone okay? Okay. You don't want to complicate things. One gas dissolve already a lot of problem. If you want to consider both the gas dissolving, then it's gonna make your whole understanding a little bit more difficult. So in this case here, let's just assume that H2 doesn't dissolve. O2, because it's more soluble, then let's make it dissolve. Okay, Ken? So if not, your whole understanding very difficult. Okay, in part C, part of the I don't remember learning this. Okay, Kyra, basically this is going to be linked up with your mole concept. So questions are never isolated in a sense. They will always be linked up with things. And you know like mole concept, it can appear in everywhere. So yeah. No, it's not about dissolving faster, but it's about dissolving more. So yeah. Okay, all of this, at the very end, I'll give you the answer key. So if you want, just feel free to screenshot, okay? If you need the annotated version. But I'll send you a more formal written, type out answer key lah. But it's just that if you want my annotation, then just screenshot, okay? I'm not against you screenshotting anything. Okay, I'm gonna continue on. Okay, part D. Explain why the deviation from your theoretical ratio of the gas collected is greater at the start but becomes less noticeable at the end. Yeah, you can. Yeah, it's not wrong. You can say that more oxygen dissolve, but you cannot say that oxygen dissolve faster because the rate has nothing to do with this. The actual volume, yes. But in this case here, why you all want to make your life difficult? Just say that some of the oxygen gas dissolve, assume that the H2 gas don't dissolve lah. But I'm not against it lah. So your teacher should mark you correct here. If you tell me that more O2 dissolve than H2. Yeah, correct. You can say that. I'm talking to Ashi, yes. As well as Kate, yes. Okay, so going back to this, part D. Explain why the deviation from the theoretical ratio of the gas collected is greater at the start but less noticeable at the end. So please take note, the whole idea of saturation. So what do you mean? So I think if you think about it, I speak to you all now, your brain is absorbing a lot of things, but your brain also have a limit. Am I correct? So it's the same thing. Water keeps accepting oxygen gas. Oxygen gas keeps dissolving inside water, but there's also a limit to how much water can hold. So what happened is, water can only hold like this specific amount of oxygen. So once you try to bubble in more oxygen, the water cannot take it. Then what happened is the oxygen gas will start to come out and be collected. So no more oxygen can dissolve. Oxygen gas starts to be collected. You will start to see this difference becoming smaller. So meaning that this 0.8 will eventually have to go back up to 1. So that is the idea here in part D. So basically, how do you explain? Very simple. Okay, you tell them, as time progresses, water becomes saturated with dissolved oxygen. So as a result, oxygen gas cannot dissolve any further. And obviously it's going to be it will start to be collected as a gas. And so that's where you start to see the 0.8 going back up to 1. So this difference starts to become less and less noticeable. Okay, so that's for part D. Now, I just share with all of you this question, okay? You go back and you take a look at the 2017 paper. Okay, let me see. So, wait, 2017. No, sorry, not 2017, 2015 paper. Okay, so you go back and you look at the 2015 paper, it came out as a TYS question. And in fact, a lot of the WAs that you're going to encounter the next few weeks, your teacher love to use this question, okay, from the 2015 paper. So they love to ask this question, especially this part here. Okay, it's one of the most, like, every year one school will ask one kind of question. So hopefully your school does ask this. But basically, this is a very typical electrochemistry question lah. Okay, so that's that. Okay. So with that, we can now discuss about the last part. Okay, 2 more experiments are conducted to investigate the differences in the product's form when molten potassium chloride and concentrated potassium chloride are electrolyzed using graphite electrodes. Now, describe the difference in the product's form. Okay, so based on what we know in part E, so the original question that we were asked was this. Okay, so the original question that was asked, I draw a very simple diagram. So this was the OG question. Basically, what happened is you have an electrolytic cell setup. Okay. And then inside this electrolytic cell, the electrodes are inert. So it doesn't matter. What you want to focus on more is the electrolyte. So the electrolyte, what you had was aqueous potassium chloride. So based on what you know, there is K plus, there is Cl minus, there is H plus, there is OH minus. So for your positive electrode, where the anode is, what happened is between Cl minus and OH minus, you choose OH minus to get discharged. Then at the negative side, where the negative electrode is, that's where you have K plus and H plus, because they'll be attracted to the negative electrode. That's where the cathode is. So that is where H plus get discharged. So this was the original question. So the new question now is, they change the electrolyte to what? Okay, so they change the electrolyte into, number 1, molten electrolyte, molten KCl. So remember, in molten KCl, there's no water. So it means that there's only what? K plus and Cl minus. So at your anode side, what you will have is Cl minus, and at the cathode side, what you will have is K plus. So the K plus is going to react to give you K metal. The Cl minus is going to react to give you Cl2 gas. So basically, what is the difference here? The difference here is for the anode, instead of having oxygen gas, you now have chlorine gas. For the cathode, instead of having H2 gas, you now have K metal. Okay, no problem. Joy. Okay, wait. Yep, here you go. Okay, who else messaged me? W slash means with. Sorry, I use a lot of short form. Okay, this means with. I no time to write full words. Sorry. Okay. Next, so this is the first new scenario that they ask with potassium, molten potassium chloride. Next, they also ask us about concentrated KCl. Okay, so for concentrated KCl, take note, concentrated doesn't mean no water. Concentrated have water. So which means that there will be K plus and Cl minus as well as H plus and OH minus. So what happens at the anode is, at the anode side, you will have Cl minus and OH minus. Normally, in normal situation, in a dilute situation, you will choose OH minus. Am I correct? But you must remember, for a concentrated situation, instead of choosing OH minus, you choose Cl minus. So which means that Cl minus will be discharged to form Cl2 gas. At the cathode, what happens is you will have H plus and K plus. Between the two, nothing changes. Still choose the one that is lowest in the reactivity series. So therefore, H plus gets discharged out. Okay, so in essence, what is the difference here? Both the new situation here, what happened is you will be getting chlorine gas rather than oxygen gas. Then for the molten electrolyte, it is different because you will form potassium metal. So take note, for the so for the electrolysis of molten, some of you wait for me. I will address your question in a minute. So for the electrolysis of molten KCl, K metal is formed at the cathode. Okay. And Cl2 gas is formed at the anode. Okay, then next, for the electrolysis of concentrated KCl, Cl2 gas is formed at the anode. Okay, ayo, my handwriting really terrible. Okay, wait, give me a minute. Is formed at the anode. Okay, yes, Estella. Is it all concentrated solution will have water? Yes. The only time there's no water if it's molten. Okay, Ray. Okay, so take note. Basically, what happened here is for part D, oxygen gas will dissolve to form dissolved oxygen. So what happened is when you are saturated, that means the water, I can only hold so much. I don't come in anymore. I cannot hold on any more oxygen gas. That's what I mean by the oxygen gas cannot dissolve any further, and therefore the oxygen gas will be collected as oxygen gas at the anode. Okay? Maybe just don't include the word oxygen. No? Okay, I think don't include this word oxygen. Maybe it confuses you. Use saturated because what is the difference between saturated and concentrated? Concentrated means you have a high amount of solids or a high amount of dissolved solid. Saturated means maximum. So it's not just high, it's like high until you reach maximum. So take note, saturated is always means maximum. Okay, that's all I have for this question. That's part E. Okay, can I? Okay, now there's one more thing I want to discuss with you, which is that if you observe, I'm going to change my color to orange because I now have too much color, so I need to differentiate it. Okay, in the original setup, what happened was your H plus and your OH minus came out from the electrolyte. So no more H plus, no more OH minus. What you are left with is KCl. Okay, in the molten situation, it's the same thing. Okay, in a molten situation, what happened is the K plus go out, the Cl minus go out. Okay, so there's nothing much to discuss here. But for the concentrated electrolyte, what happened is, take note, the H plus go out, the Cl minus go out. So what is left is slightly different. You're left with KOH. So I think it's also important that you bring out that for the electrolysis of concentrated KCl, what happened is KOH is left as the electrolyte. Okay, so that is all I want to say about part E. Okay, come. Why do you need to talk about the cathode? Because the cathode produces H2 gas, which is the same as the original setup. Am I correct? So is there any difference? There's no difference. Remember, the question asks for all the differences. So having H2 gas is not a difference. Okay, next, HM. Then when O2 starts being collected, isn't... So it's the same idea law because we must remember H2 gas is less soluble. So if O2 gas, so that's the situation why I keep saying don't need to consider the O2 gas, the H2 gas dissolving because it will make your whole situation very complicated. So I think someone was asking if the O2 gas is start being collected as a gas, can the H2 gas still dissolve? The answer is yes, but H2 in general is a very insoluble gas. So in this case here, what you should focus on is make your life easier. Don't need to keep thinking about the H2 gas. Just assume that the H2 gas don't dissolve. The O2 gas is the one dissolving. Then your whole life will be so much less complicated. Yes, it does. Because basically, didn't we say that? Do you see that the volume is 2 times? So basically, in part B itself, why did we say that the volume ratio is 2:1? Is because it's 40:20, what? Right, Lyra? Oh, why is oxygen gas more soluble than H2 gas? I don't think you want to open up that can of worms lah. It's not in syllabus, so don't need to understand. You don't need to know why. Okay? You just need to know that it is more soluble. Yes, in a not a normal aqueous. So someone was asking, in a is it in a normal aqueous solution? Is always H2O being selected for discharge? I'm gonna be honest with you, no. Why is because if I change the question up, okay, so this is where I want to go back to my summary page. If I change up the electrolyte into copper 2 sulfate, correct? So if let's say today my electrolyte is copper 2 sulfate, dilute copper 2 sulfate. Then what I will have is copper 2 plus SO4 2 minus, H plus OH minus. So in that kind of situation, you don't discharge H plus out because copper is lower in the reactivity series. Copper needs to come out, right? ZH. So Ken, I will explain. Give me a minute. Okay. Okay. So let me just go back to that last question first. Okay. So going back to just now that question, so why is it that KOH is left behind? Because based on what we know, in a concentrated electrolyte, instead of choosing COH minus, you will choose Cl minus to get discharged out. So Cl minus get out, OH minus is left behind. In the cathode side, H plus, K plus, H plus get out, K plus is left behind. So these two ions are being discharged out. What is left behind is the K plus and the OH minus. So that's why K plus and OH minus is left behind. It's left behind in the electrolyte. Everyone good? Okay, I think most of you are okay. Now let's move on to the next cell. Okay, so to wrap up electrolytic cell, there's one part I need to talk about. Okay, so number one, I remember just now we say, first thing first, we dissect the diagram so that we can identify where the cathode and the anode is. After that, what we do is we use the framework here. So remember, your SOP, your standard operating procedure when it comes to electrochemical question is, step one, look at the diagram, dissect the diagram first, figure out where your anode and your cathode is. Then you use the framework and you work out what are the ions that will be discharged at the cathode and the anode. Correct? So step one, ask yourself, is the electrodes inert? Inert means they don't participate. You don't need to care about them. You focus on the liquid, the electrolyte. So if it's molten, there's only one set of ions. So the cat ion go to the cathode, the anion go to the anode, then they get discharged out. But in an aqueous electrolyte, whereby there's dilute and concentrated, what you have is more than one set of ions. So when you have more than one set of ions, you need to make a choice. So you need to choose. So how you choose is, remember, cathode, use the reactivity series and choose. Anode, always remember this, always choose OH minus. Unless you're dealing with a concentrated electrolyte, then what happens is, if it's Cl, Br, and I against OH, choose Cl, Br, and I instead of OH. That's as simple as that. Okay, so that is the inert part. Now let's deal with the reactive part. So if let's say today I have reactive electrodes, okay, what happens? Okay, now you need to deal with it two ways. So you need to focus on the anode and focus on the cathode. Okay, so what do I mean? For the anode, what you need to remember is this. The metal anode will undergo oxidation. So the metal anode will be the one oxidizing and it will form the metal ions. So for example, like your copper anode will undergo oxidation to give you copper ions. Next, what happened to the cathode? Remember, cathode is like calefare. They just stand at the background and don't do anything. So a reactive metal cathode will never participate in the reaction. Who participate in the reaction? It is the cation ions inside the electrolyte. So the metal cation ion inside the electrolyte will get preferentially discharged at the cathode. And how do you choose? Same thing. reactivity series. So always remember, cathode cations choose using reactivity series. Okay? Anode always choose OH minus unless two situations. You got a concentrated electrolyte, you choose Cl, Br, and I. You have a reactive electrode, then you let the metal anode dissolve on its own. Okay? Now, from here, basically, they will test you on these three situations: electrolysis, electroplating, and electrolytic purification. Unfortunately, I don't have time because I still have to deal with electric cell. So what I want all of you to do is get ready your screenshot. I will send you some notes on this. Okay? Okay, so these are the stuff that I went through in class. I'll just share with you all. So when you have a reactive electrode, for example, something like this, I'm doing the electrolysis of sodium chloride using reactive copper electrode. So basically, the idea for reactive electrode is very simple. You just think of it this way. Anode dissolve, whatever is inside the cation or inside the electrolyte, the cation goes up the cathode. So I repeat again, the idea is very simple. For reactive electrodes, you think of it this way. Anode dissolve, whatever cation is inside the electrolyte go up the cathode. Okay, so that is basically what you see here. If you don't mind, just take a screenshot of this and then go back and read about it. Okay. Okay, next, the two application, electroplating, electrolytic purification. So for electroplating, it looks something like this. So you must always remember, electroplating is what? You imagine the Oscar statue, you want to put a layer of gold on it. So what happens is, gold must dissolve, move over to cathode, and go up the Oscar statue. Okay? If I'm not wrong, today is Star Awards. So you think of it, you want your trophy to be gold in color, to be gold plated, gold put at the anode, let the gold dissolve. Inside the electrolyte, ask the gold to go up the cathode to be plated onto the object. Okay, can? Now, don't be a smart Alex. Okay, what do I mean by don't be a smart Alex? Okay, so what happens is, if you are putting gold onto your object, then your electrolyte, please choose something that's related to gold. Don't give me like zinc or iron or magnesium, because that kind of extra ions may interfere with the reaction. Understand? So if you are, for example, I want to plate zinc metal onto my iron object. All of you learn about this in your reactivity series, galvanizing. So galvanizing is I'm putting a layer of zinc onto my iron object. So to do that is very simple. Put the zinc metal at the anode, let the zinc metal dissolve, move over to the iron object and go up the iron object. Okay? So take a photo of this. This is your electroplating. Okay, next. What is electrolytic purification? So electrolytic purification is obviously you want to purify an impure metal. So for example, like if you see here, okay, I have an impure metal, impure copper. All the circle here are all the impurities. So basically what you need to do is allow the copper metal inside this impure sample to dissolve, the purple color part. So when the purple color part dissolve into copper ions, then all this impurity will fall to the bottom as anode sludge. What happened is the copper dissolve already, move over to the cathode, go up the cathode. Understand? Okay, everyone good? So please do take photo of this. This is your electrolytic purification of copper. Okay, now, so this covers the first part of electrochemistry on electrolytic cells. That means cells that you use to do electrolysis, electroplating, and electrolytic purification. However, there's one more type of cells called an electric cell or a simple cell. So the second type of cell we are looking at is electric cell. What is electric cell? That means electric cells is the opposite of electrolytic cell. Electrolytic cell is I use electricity to generate chemical reaction. In electric cell, what you are doing is you are using chemical reactions to generate electricity. So how you do that? Same thing. This time around is use framework first, then do diagram. Okay, so what do I mean by use framework first? Number one, you will need to ask yourself two questions. Question number one is meant for the anode. So to determine who is the anode, you need to ask yourself, which of the metal is more reactive? Okay, now, important thing to take note of is in an electric cell, the two electrodes or the electrodes that you use must be of two different metals. So they must be of metals of different reactivity. So the electrodes must be made of metals of different reactivity. So they cannot have the same reactivity. They cannot be the same metal. Okay? And all the more, they must be reactive. So the electrodes must be reactive electrodes, and they must be made of metals of different reactivity. Then what you ask yourself is, question number one, for the anode, which metal is more reactive? So the metal that's more reactive will tend to undergo oxidation more readily. So that's why it will form the anode. So what are you going to observe is this. The more reactive metal will be the anode. And remember just now we were saying reactive anodes always dissolve to form ions. So in this case here, if you look at zinc versus copper, zinc is more reactive. So because it's more reactive, it tends to undergo oxidation more readily. So that's why it will form the anode. Now, remember just now what we were saying? Oxidation always lose electrons. So basically, pardon my language, you think of it as when the zinc react, the zinc shit the electron out. So the electron must come out from the anode. Now, you think about it, you want to push the electron over to the other side. So how to push an electron that is negatively charged over to the other side? It needs to be negative. So the anode must be negative to repel the electron over to the other side. And the cathode obviously must be positive to attract the electron. Because your cathode, at the cathode is where reduction happens. And for reduction to happen, usually it needs to gain electrons. So reduction is also where the cathode is. So please remember, your less reactive metal will form the cathode. However, the idea doesn't change. So you must always remember, cathode don't participate in the reaction. So the less reactive metal will form the cathode, but the cathode don't participate in the reaction. So that means the cathode will not do anything. What will happen at the cathode is the metal ion. So the metal ion inside the electrolyte will get discharged. And to discharge it is we use the reactivity series. Okay, so let me go through this work example that you see here. So based on what we know, zinc and copper, zinc is more reactive. So because zinc is more reactive, because zinc is more reactive, zinc will dissolve to give you zinc ions. So that means if you can see here, the zinc metal will slowly produce out the zinc ions. Next, inside your electrolyte, what do you have? Aqueous copper 2 nitrate. So you have copper 2 plus, NO3 minus, H plus, OH minus. So obviously what you do is you send your copper 2 plus and your H plus over to the cathode side. So at the cathode side, what you see is Cu2 plus and H plus. These two come from the electrolyte. But don't forget, your anode is dissolving to produce zinc ions. So your zinc ions is also coming from the anode. So between these three, you need to choose who to get discharged. Remember, reactivity series. So the lower, the better. So out of these three, copper will be the one getting discharged out. So in essence, you must remember, for electrochemistry, how we use the reactivity series is we think of it this way. For the cathode, the lower the better. The lower, the more likely the ion will come out. Okay? Okay. I got last few parts. Okay, fuel cell here. For fuel cell here, what I can advise all of you to think of is this. For some of you, I think you already started on your your organic chemistry. So in organic chemistry, you learn about fuels. Fuels are burnt, or fuels undergo oxidation to form energy, correct? So you think of it this way. In a fuel cell, there will be two things: a fuel and an oxidizing agent. For example, like H2 is the fuel. So H2, the fuel must undergo oxidation. So you put it at the anode. So you think of it this way. The logic thinking is this. Fuel, based on what we learned in organic chem, have to undergo oxidation. Anox, so oxidation, put at anode. Next, so something needs to oxidize the fuel, which is your oxidizing agent. So your oxidizing agent will undergo reduction, so you put it at the cathode. So that is what you are looking at here. The H2 fuel put at the anode, oxidation. The oxygen gas is the oxidizing agent put at the cathode for reduction to happen. I am sorry to say I would advise you to just memorize these two equations. You want to derive is not a problem, but I feel it's very hard for O-level students to derive. So usually I would say you just memorize. Okay? Now, your exam question may come out as a alkaline electrolyte or acidic electrolyte. So what happens is, depending on whether is it alkaline or acidic, then you just choose the appropriate equations to choose. Okay? The last part of today is take note of the differences between the electrolytic cell and electric cell. So I've highlighted all the similarities, all the differences. The similarity, what I want to talk about is this. Always remember, anox, red cat. Number two, always remember, anode to cathode is where the electron flow. Last but not least, what I want you to remember is, I don't know, just now I didn't really point this out, but if you take a look, in an electrolytic cell, your anode is positive, your cathode is negative. But in an electric cell, you see the polarity switch. Anode is now negative, cathode is now positive. So how do you remember? You remember it this way. Okay, this box here. If you have a battery, your anode cathode, you use the battery to help you to judge. If you don't have a battery, then you need to judge it based on the reactivity of the metal. More reactive, anode push the electron out, so must be negative. Cathode accept the electrons. Okay, is there any more question I want to talk about? I think what I'll do is maybe I'll just quickly go through question 9, okay, itself. Okay, so as an application for this. Okay, question number 9. A student investigates the potential difference of voltage set up by various simple cells. Now, the metals that are available are copper, iron, and zinc. The figure below shows the experimental setup by the student. Okay, now depending on the electron flow, the potential difference may be positive or negative. Okay, if it flows from Y to X, is positive. Okay, now the potential difference here, if you see the first one is 0. So remember what I said. The two electrodes must be made of different metals. If the metal is the same, then there's no difference in reactivity. There's no reaction. So no reaction means no potential difference. So in this case here, the first metal here will be iron. Because there's no there's no potential, there's no reactivity difference. Next, you want iron. Okay, so next, the second part is negative. Negative means the electron is flowing from X to Y. Remember what we were discussing just now? Anode will always shit the electron out. So which means that your X is the anode. Okay, maybe I will color code all of this in red first. Okay, so take note, we're talking about this in red. So the value is negative, suggesting to you that X flows over to Y. Okay, then next is your thinking process is the electrons need to come out. So for electrons to come out, that means X must give the electron out. Okay, so X will therefore be the anode. So what happened is, based on what you remember also, therefore it must be more reactive. Okay, the cathode is the one accepting the electrons, so the cathode is less reactive. So what you need to do is you need to choose a metal that is less reactive than iron. In this case here, between zinc and copper, obviously the answer is copper. Okay, so this is this situation. If you need to take a screenshot because I'm going to scrub this away. Okay, 5, 4, 3, 2, 1. Okay, so I'm going to scrub this away. Okay, next, in the second situation here, I have a positive value. So based on what the question says, the positive value, Y is going to X. So Y, the electron, come out, go over to X. So you must remember, the one that is producing the electrons is always the anode, because the anode undergo oxidation. So in this case here, what metals will become the anode is always the more reactive metal. Okay? Then your X is the cathode. That is where reduction happens. So in this case here, what happened is the less reactive metal. So I need to choose a metal that's more reactive than iron. I will choose zinc. Okay, so that is part A. Then I just finish up part B lah. Okay, so part B, state the negative electrode of the simple cell with this potential difference of plus 0.6. So remember, you want to push the electron away. So it needs to be negatively charged. Or it needs to be negative. Because based on what you learn, like charges repel. So you want to repel the electron, you need to be negative. So this side needs to be positive. So basically the negative electrode would be metal Y. Okay? Y, okay. Then after that, explain your answer in terms of the direction of electron flow. So basically is for the iron, zinc simple cell, electron flows from the more reactive zinc metal to the less reactive iron metal. Okay, so that is part B. Now the rest of the question, I will pass you all the answer. Okay, Because the last of the remaining question, not really worth discussing. It's more of A and B. Okay, I have some questions. No, you can't say lead. You know why? Because the question already say is copper, iron, and zinc. So if you say lead, it's out of the context of the question. Okay, ZH, wait, let me just try and, yeah, no problem. Just give me a minute. Okay, we can memorize the equation, but aqueous solution, the anion is based on the Q. Based on the question, not always OH minus. But you must think about it. As long, most of the exam question will always give you aqueous, dilute, or concentrated electrolyte. So the aqueous is always got water. Got water will always have OH. So that's why. Unless, what are you talking about in this memorization of equation thing? Can enlighten me. Okay, now if you all don't mind, just let me do a few debrief, and then what I will do is I will stay back. If you all don't mind, you all can stay back. Anyone have any more questions, feel free to ask after this. Okay, so just give me 5 minutes and to wrap this part up. Okay, so I think most of you are from Overmark, but for those of you who are not from Overmark, maybe what I'll do is I'll just share with you some of the resources that we have. So in terms of resources, I think what you can see here today is there's curated notes, but I never pull out the curated notes from our center lah. What I provided all of you more was WA revision summary notes as well as exam questions that will probably come out. Okay, then moving forward, I think the next few terms, the next few weeks, you will see the June crash course coming out as well as the practical mock practical that's coming up. Okay, so just in case you're wondering, okay, if I want to sign up for tuition, where can I go? So you can always scan this QR code or you can visit the Overmark website. FYI, if you're interested in coming for my class, I teach at Bishan on Tuesday, from 5 to, no, Bishan on Tuesday, yeah, here, me, 7:30 to 9:30, okay? But I only have one Sec 4 class. Okay, but more importantly, I think is we are approaching the end of the syllabus as well as approaching into exam season. So I think if you enjoyed this session and you're looking at the crash course itself, I think more importantly is go and sign up for the crash course that's coming up in June. Okay, I'll just leave this here for a minute. Do I need to make notes for chemistry? If you're in my class, usually what I'll do is I will make the notes on the spot with you. It's a summarized version of the curated notes. But for organic chemistry, usually I'll just give my student my notes lah, a set of notes. I think it's 8 pages for the whole syllabus itself. On organic chem. Okay. Yeah. So do you need to make notes? If you do join us, then probably not. Okay. Last but not least, I think most of you are looking for the answers. So what happened is you scan this QR code. Okay. I will put the answer key inside the folder right now. It's basically the same folder. It's just that I never put the answer key earlier. Okay, so just give me a minute. Let me just slot the answer key in. Then after that, I will stay back and answer all of your questions lah. Okay, give me a minute. 2026. Okay. Okay. I'm uploading the answer key. Number one is to answer Joshua, I think number one is get the syllabus done and over with. I think more importantly is put more focus on practicing your prelim papers as well as your TYS papers. For O levels, basically it's if you put in the hard work, you will get the result one. So it's really about just doing the TYS towards the end. But you do the TYS, but no one mark for you, or no one go through with you, is also a problem lah. So basically I'm looking at doing the TYS papers after I finish practical in June. So yeah. Long. But just work hard lah, and then just do your papers diligently. Okay, I think that's all I have. So um okay, I'll talk to you privately. Give me a minute. Okay, so I think that's all I have. Please scan this QR code for the answers. If not, if you have any questions, feel free to stay back and ask about your WA. Okay, I will leave the floor open right now. So anyone have any questions, just bring it on. Okay. Is Joshua still there? Okay, I've asked what must I do to understand better? Hard time understanding chemistry. Like what part of chemistry you don't understand? Like everything, or it's more of practicing you cannot do? Okay, everything. I think now at this junction in time, you still have time lah to get your B3, A2, A1. Number one is I think maybe you want to consider coming for the June crash course, because the June crash course itself, we will try to summarize for you the whole syllabus inside 3 modules. So in a way, what happened is you can get a better understanding of what are the important things inside each topic itself, and more importantly is practice lah. Understanding itself, actually O levels, to be honest with you, the understanding is not very important. It's more of practicing is more important. Okay, Chloe, do you have classes at Tampines? I don't I only have J2 classes at Tampines lah. I mostly teach at Bishan. Yeah. Tampines wise, I don't know who. Yeah, I usually teach at Bishan now. But maybe you want to tell the admin that you're interested in my class, then they might give me one class. Ha ha ha. Okay. ZH. For the overmark practical, do you guys go through all types of practical that can come out with, and also how to study for practical? No, practical is not random. Number one, there is a pattern to it. Do we go through all types of practical? Yes. When we do the theory prep, but usually for the hands-on practical, we will focus more on likely what will come out for O levels. So your practical got 2 parts: the hands-on portion and the theory portion. Theory portion meaning that what do you need to write for your exams? So for that itself, we will go through all the different types of practical. But for the hands-on part, I think we will focus more on 2 skills, QA and titration, because these are the 2 that need more practical skills. The rest, actually, technically, mixing of solution, I mean, like you just measure properly and mix lah, so that there is not much problem. So the skills that we're going to go through for practical is titration skills, QA skills, how to write the exam, like how you write your tables, how you plot the tables, how you plot the graphs, as well as for your QA itself, what do you need to write? What are the things you need to write? So for example, like if you are testing for a gas, we must always write 3 important points. So that is what we are doing in the practical itself, lor. Okay, QA itself, you need to memorize if it is theory paper. If it's practical paper, they will give you the table. Okay, the lab is more of a makeshift lab. It's not like some other tuition. It's not like your school lab lah. But don't worry lah. Everything we ensure safety, so that's the most important part. So as you are doing the hands-on practical, that it will be very safe. It's just that it's a makeshift lab. Okay. Anyone have any more questions from electrochem? No, it's definitely a curve law because yeah, it makes sense. What? Why would the temperature, the heat be constant? Is once the reaction is over, then there's no more heat coming out, so your heat will stay the same. So, in general, the curve should look something like this. Give me a minute, Hmm. Hmm. Yeah. Hmm. Wait, sorry, where is my practical? Yeah, so basically, for temperature question, the graph you're looking at is usually like this lah. If it's a constant graph, that means it will make sense lah. If you are plotting, okay, wait, if you plot another kind of graph, then yeah, it should remain constant law. Yeah. Okay. Okay, wait, Marilyn. Yes, okay, can Marilyn and yes, you must know exactly how the electron flow in your electrolytic cell and your simple cell, which is anode flow to cathode. Okay? Okay, let me help Marilyn. Okay, for those of you who are lost and then I ask you to stay back. Marilyn and Ding and Shile. Okay. Okay, so basically what happened is, remember, electrochemistry is all about making right choices in life. Okay, so what do I mean by making right choices in life? So basically what happened is you will be given a diagram to dissect. Number one is you need to know whether is it an electrolytic cell or electric cell. It's very simple. An electrolytic cell is basically whereby you have a battery. So what you need to do is, how do you know where your cathode and anode is? So remember, you look at the battery. The long side of the battery is positive, which means that the electrode attached to it is positive. So what happened is, positive electrode, if you put it inside the electrolyte, what kind of ions does it attract? It attracts anions. So therefore, to let the anions know that you are supposed to come over here because I am positively charged, I'm trying to attract you. What we call it is, we call it the anode. Then next is, based on what we know, anox. So anode oxidation. So the anode will undergo oxidation. Okay? But you remember in redox, oxidation means you lose electrons. So the electrons will come out from the anode. Marilyn, okay? Sheila, okay? Yeah, can. Okay, then next, the negative electrode, okay, or rather the negative terminal of the battery will be attached to the negative electrode, or rather the electrode that's attached to the negative terminal of the battery will become negatively charged. So when it's negatively charged, it needs to attract cations. So it's where the cathode is where reduction is. So that is also why the electrons have to flow over to the cathode side, because that is where electrons will get picked up. So number one is you look at the diagram, you dissect the diagram based on the battery to know where your anode and cathode is. After you are done with that, then you are ready to start to predict what are the products at the cathode and the anode. So to do that, what you need to do is you need to ask yourself three very important questions. What are the three important questions? Question number one is you ask yourself, if you look at the electrodes, the metal blocks here, are they inert or are they reactive? If they are inert, that means they don't react. So they will not participate in the reaction. They don't do anything. So everything will be based on the liquid, the electrolyte. Okay, so if they are reactive, then they will participate in the reaction. So how do they participate is the idea is the anode will dissolve. Then the anode dissolve, whatever is inside the electrolyte, the cation, go up the cathode. Okay, can? Okay, so we follow the inert idea first. So if your electrodes is inert, then basically they're not very important, correct? Inert electrodes won't dissolve. They don't react. They just stand there and do nothing. Understand? Not say do nothing lah. They help you to complete the circuit, but they will not dissolve. Only the reactive anode will dissolve. Okay? Okay, Estella, give me a minute. Let me just address all of your issues one by one. Got quite a few questions. Okay, so next. So the electrodes are inert, they don't participate. So you focus on the electrolyte. So you ask yourself the question, is the electrolyte molten or aqueous? What is your understanding of molten? Molten means no water. That means they will not give you H plus and OH minus. So in a molten electrolyte, you only got one set of ion, coming from the salt itself. So it's the Na plus and the Cl minus. Then it's very simple. Remember, Na plus cation go to the cathode, will get discharged out as the metal. So that was what I was saying here. The metal ion becomes the pure metal. The Cl minus, it is the non-metal. It will go to the anode side. So it will get discharged out as the non-metal. Okay? Okay, next. If it's aqueous electrolyte, then you need to consider the possibility of water. So what happens is, if there's water, then it can give you H plus and OH minus. So we start with dilute first. So in dilute electrolyte, there is your salt and your water. So the salt will split up into Na plus and Cl minus. The water will split up into H plus and OH minus. Same idea. Send the cations to the cathode. So you have Na plus and H plus. So you have two ions, right? So when you have two ions, you need to make a decision. You need to choose who to go out. So both cannot go out at the same time. One must go out first, then the other. So in this case here, between the two, how I judge it is I use electroreactivity series. So the lower the position, the more likely it will go out of the electrolyte. So in this case here, if you see H plus, hydrogen, lower than sodium, so hydrogen go out first. For your N ions, Cl minus and OH minus, you send it to the anode because that's where the N ions are. So between the two, by right, you're supposed to use the electrochemical series. But what I was saying is almost 100% of the electrolyte always have water. So when you have water, you have OH minus. Why do you want to consider any other thing? Just send the OH minus out. Okay, so this part, I pause first. Marilyn. Okay. Why? What happened? Okay, which part you don't understand? Okay, wait, Stella. Oh, okay, what are fuel cell used for? Okay, can. Give me a minute, one by one, Sure. Okay, do you need to memorize anything about QA? Yes. For QA, do I need to memorize all the colors and reaction? Yes. What's the best way? I think the best way to remember is compartmentalize them. So take note, QA, usually you got three types of PPT, colored, white, and no PPT. So from there, you just see, remember, colored got three. Copper, iron. Copper, iron 2, iron 3. White got 3. Zinc, aluminium, and calcium. Then no PPT, only got one ammonium ion lor. Okay, wait Marilyn, okay all of you so far, all okay Okay, so from here, from dilute, we move over to concentrated. So for concentrated electrolyte is basically you got lesser water, more salt. Okay, what happens is, just remember, concentrated electrolyte will only affect anode. It will not affect cathode. So yes, in the salt itself, you have Na plus and Cl minus. In water, you have H plus and OH minus. Send these two ions to the cathode. Na plus, H plus, but remember, the reaction does not change. So you still choose based on reactivity series, the lower the better. So you choose H plus more. Okay. However, like what I was saying, you must remember, concentrated electrolyte always will affect anode and will always affect two groups of ions, Cl minus, Br minus, and I minus versus OH minus. So originally, usually we choose OH minus. But if you have a concentrated electrolyte, the anode will be affected. What you do is, instead of choosing OH minus, Cl, Br, and I will be preferred. Okay? Okay. Why? Not at your level. I think some of you might be wondering, why must choose Cl, Br, and I? It's an A level thing. But anyone here from IP, if you are, you can like sound off. I will explain to you. Because the IP students need to know. O level students don't need to know. So you just need to know you choose this. You don't need to know why you choose this. Okay? Can Okay, I think that's all. Sheila, got anything not? Nope. Okay. Okay, can. Wait, I still want to address Estella's question. Okay. Is it all concentrated solution will have water? Yes. But it's just that the water is little. So what is the difference between dilute and concentrated? Dilute is a lot of water. Huge amount of water. Concentrated is very little water. Okay? Okay, next. For reactivity series, do we need to memorize what will happen when metals react with water, steam, and acid? Yes. So just in case, I think all of you here quite benefit. Okay, so anyway, just in case you need to remember the reaction, you just think of it this way. Where is it? No, this is energetics. Reactivity series. Okay. So you think of it this way, this was what I told my students to remember. So you just need to remember, where's my reactivity series? Here, this is the summary page. Okay, so you just need to remember, for reactions of metal, you think of SWAD, steam, water, acid displacement. For steam, you just need to remember SOX, SOX. So the product it forms is a metal oxide. For water, you think of WHO, WHO, hydroxide. So the product it forms is hydroxide. Next, which metal will react with WHO? You just remember steam, iron, water, magnesium, acid, hydrogen. So you remember Institute of Mental Health, IMH. Then can already. Okay? Okay. Oh, and how do we get a negative value for simple cell? So simple cell itself, you have to see the context of the question. Okay. Because the context of the question is they will tell you how the electron flow and which electron flow is positive, which electron flow is negative. So for example, like just now, question 9 itself, correct? For question 9 itself, they already tell you that if the electron is flowing from Y to X, then it's positive. So that's how I know that if it flows from X to Y, then the value will be negative lor. Okay? Okay, and then last but not least, what are fuel cell used for? A fuel cell is to provide you with energy continuously. So as long as you feed it H2 and O2 gas, it will keep giving you energy. So usually what happen is this, let me just kind of share this with everyone. Okay, so for fuel cell, basically it's usually used in rocket. So what happen is you have the fuel cell here. So the fuel cell, what happen is if you give it H2 and O2 gas, the fuel cell will give you energy. But remember the reaction itself, you end up producing water, correct? So the water comes out, then what do? Don't waste the water, put it inside an electrolysis experiment. Because in an electrolysis experiment, the water will break down to give you H2 and O2. So then you just continuously supply lor. So usually that's what we see in a rocket ship lah. If you watch documentary about Voyager 1 and Voyager 2, the two Voyager that went to Saturn and Jupiter, so they were launched in 1965. They just recently reached, I think last 2 years, they just recently reached Saturn, Jupiter, Uranus, and Neptune. So what happened was, you think about it lah, they travel for like 40 over years. How did they get this energy? It was to use something like this lor. The fuel cell provide the energy, produces water, water go into electrolysis, come out as a reactant. Then your reactant go back in again. Okay? Okay, next, Joshua. Okay, Joshua, wait, I see. Let me talk about Chloe first. Okay. Teacher, when they say what observation is seen, is it I need to refer to my QA? Yes, but if you are doing a theory paper, you don't have the QA table, so that's why you need to memorize. So that also answer Joshua's question. Need to memorize, yes. If it's for theory paper. Okay. Okay. Oh, how to memorize QA? I break it down lor. Okay, maybe I'll share with you all how I memorize it. Where's my QA? Okay, wait, give me a minute. Let me use my Sec 4 class last year. Okay, wait. Okay, wait. I use my Sec 3 class my Sec 4 class this year. Okay, QA, okay. So usually for QA, how I memorize it is, sorry, I know I annotate a lot of things. So usually what I do is I just remember, there are altogether 3 kinds of PPT: colored, white, and no PPT. So for my colored PPT, what happened is I just need to remember copper, iron. Okay. Then for my white PPT, I remember my good friend Zach, zinc, aluminium, calcium. And then for my no PPT, I remember ammonium. And then from there, you just need to remember the PPT form is always a hydroxide. So that is my tips lah. Okay, Cloud 8. When are my classes? Tuesday at Bishan, 7:30 to 9:30. If traveling is an issue, you may want to consider online. Then you don't have to travel lah. Okay. Okay, any other questions? So that's the tip lah. And then for anions, how I remember it is there will be 2 kinds. Okay, so anions I think is quite simple. Carbonate, nitrate will produce gas. Sulfate, chloride, iodide will produce PPT. So just need to remember, you match the correct metal ion to the PPT itself. So example like barium match with sulfate, chloride and iodide match with silver lor. Okay, Joshua's question. I just started learning about hydrocarbons. Can give a heads up about what is it all about? It is all about organic chemistry, which is a different branch of chemistry. But it's the one that will come out the most in exam. Yeah, so about I think 30% of O-level papers is usually for each year is on organic chem. So yeah, for those of you who are online, please treat it seriously. Okay. Sorry. Yes. Okay. I missed out VS question. Okay. Must we know exactly how the electron flow? That one I explained to you. Yes. You need to know how to go from anode to cathode. Okay. How do you explain those questions that ask like the color fades for the copper? Okay. I will explain the copper thing again. Okay. I'll use my electrochem topic here. Statistics. No, this energetics. Give me a minute. It's my electrochemistry. No. Okay, here. Yes, okay. So to answer VS question about electrode the color of the electrolyte fading. That one I never really touched on it. But the idea is this, very simple. We all know that copper 2 sulfate is blue in color. So what happened is, for example, like in this situation here, or rather in this situation here, the electrolyte, the blue color electrolyte will not fade. It's because as your copper is going up the cathode, there is copper ions coming from the anode. So you think of it this way. I'm losing copper at the cathode, but I'm also replenishing the copper at the anode. So there is no loss of copper ions. So your color only fades if you lose copper ions. So that means the copper gets discharged at the cathode, but there's no copper coming in from the anode side. Then can you explain the saturated question that you have gone through previously? Okay, Ken. Okay, the question is just very simple. The idea is this. Okay. The idea of being saturated is this. Saturated means I'm holding maximum. So you imagine I'm holding maximum amount of oxygen already. So if I'm already at capacity, I hold so much oxygen. Can more oxygen come in? The answer is no. So I cannot hold any more oxygen. Water cannot hold any more oxygen. Then oxygen will start to be collected, lor. So as a result, when oxygen starts to be collected, then there will be no more difference anymore. Oh, my specific question was like, why the saturated water isn't the electrolyte potassium hydroxide? Thanks. Sorry, okay. What do you mean by your specific question? Because I don't really get it. No, because if you are talking about part E is a different scenario. So concentrated is not saturated. Concentrated means the concentration is high. Oh, part D. Why saturated in water isn't the electrolyte? No, but remember the electrolyte is potassium hydroxide, right? But it's aqueous potassium hydroxide. So there is still water, what, right? Correct? So that's why it will dissolve inside water, lor. Okay. Come, let's I'm doing rate of reaction this week. And then after that, in May, I'm doing organic chemistry. So I'm doing rate of reaction before May ends. Actually, I'm doing more concept revision and rate of reaction first. So more concept revision, rate of reaction before May. And then when May starts, I'll do organic chem. Starting from scratch. Then after that, June, I'm doing revision for acid base and QA. Okay, 湿了 Can you go through the equation thingy again, the one where we do the reaction with the electrons? You talking about this one here, A? Sheila, is that what you're talking about? Okay, so basically what happened is we already know that the cathode is this reaction, right? Correct? And the anode is this reaction. So now the issue is we know that our two reactions at our cathode and anode is here. Okay, so separately, this is the equation that happens at the cathode. Okay, wait, let me just. So basically, this is the reaction that's happening at the cathode. This is the reaction that's happening at the anode. But what we will want to do is we will also want to combine the two half equations together to form a full equation. So to combine the two half equation into a full equation, what we need to do is to ensure that the electrons are the same. So to ensure, okay, how did we get these two equations? Oh, so we get these two equations is because we dissected the diagram, right? So remember, your electrolyte got K plus, OH minus, H plus, and OH minus. Am I correct? Right? So based on that whole procedure that you did, then what happened is you send the K plus and the H plus over to the cathode, right? Between the two, who is lower in the reactivity series? Hydrogen. Am I correct, Sheila? So the H plus will come out as H2. You have to know how to derive out law. So the H plus will come out as H2 gas. Then what happened is the other side, what happened? Why is the Okay, very simple. I teach you how to derive out, okay? So basically it's H plus become H2 gas. Okay? So number one is you balance the atoms first. There's two hydrogen here. You will need to put two H plus here. Okay? Next is, if you think about the charges, on your left-hand side here, each hydrogen is a +1 charge. You got two of them. So it's a +2. Right? Yes, then H2 gas, no charge. But take note, you want to balance the charges, what must you do? You must bring the charges down. You cannot bring it up because you add electrons. So that's why you add 2 electrons. So -2 so that you get 0. Okay, can I? Okay, then the other equation here is I ask you to memorize because it's very hard to derive out. Basically, what happened here is you will discharge the OH minus. So to discharge the OH minus is best you just memorize this equation. Easiest way lah, will not go wrong. Then once you have these two equations, then you want to combine them together lor. So to combine them together is to ensure that the electrons are the same. So that's why the first equation I will times 2 lah. Correct? Then the second equation times 1. Then when your second equation times 2, then you get a situation like this, and then you start to combine and cancel lor. Okay, next one. Okay, BS left already. Estella. Wait, so for the copper 2 sulfate question, is it when the anode finish reacting, then the blue electrolyte will start to turn light? So the situation is this, if the anode stop reacting, there's no more anode, right? The circuit also broken. Am I correct? So the cathode, right, it will be quite hard for the cat ions to get discharged at the cathode because the reaction is like done deal. It's like no more already. So yeah lah. But in a way, yes lor. So if there's no ions coming, if there's no copper 2 ions coming from the anode, then your blue electrolyte will start to fade. Okay. Anyone have any more questions? Yes, Sheila, you unmute yourself. You want to say something? Oh, okay. Can. Okay, sure, no problem. Okay, anyone have any more questions? Feel free to ask. Okay, one more question. Stella. Okay. Wait, so once the anode finish reacting, no electrons can flow, then yeah, because the copper has already dissolved inside the electrolyte, right? So basically the idea is this, this is your electrode, right? This is the electrolyte, right? Basically, you're telling me is the anode no more already, what? So if the anode no more, there's a gap here, the circuit is broken, right? If you take physics or even if you do Sec 2 science, you will know lah. There's nothing, there is a gap here. The circuit cannot flow, the electron cannot flow, nothing can flow. So there will be no more reaction, no? But the electrolyte will still have copper 2 ions. Then the color will stay the same. Yeah, it will still be blue because there's still copper ions inside. Right? The only time copper ions will not be inside is if let's say you have an anode here, but the anode don't give. So we are saying why the copper stays the same is because copper come in from here, copper leave from here. Am I correct? But why the color will fade is your copper leave, but there's no copper coming in. So you lose copper ions, then you will lose the color. Can upload the answer key here before. The answer key, just refer to the Google Drive link. I pass it to you. Yep, I put it inside the Google Drive link already. And the Google Drive link will stay lah for about maybe a month. So you can always just come back and just download it. Julie, okay not? I send you the link directly. Yep, you just go into the link, the notes, the answers all are inside. It's just that I never put them together. Okay. I hope I answered everyone's question. Yeah. If I miss out anyone's question, I will probably put inside the Telegram chat lah. Okay. And then yeah. Okay. I guess that's it. Anyone have any more questions? Feel free to ask. I'll probably stay back for another 5 more minutes. Okay. Telegram chat. The Overmark Telegram chat. Let me just drop the link. You can always join the Overmark Telegram chat. Wait, let me see. I drop you the link lah. Yep, the Overmark Telegram channel lah. So just in case anything, you need. Why I cannot send? How do I send this? Okay, wait. Let me just. Okay. I sent it to you already, Sheila. Yep, you can just join the Telegram chat. Okay, I'll put it inside the main chat as well. So anyone who is not subscribed to the Overmark Telegram channel for O levels, feel free to join us. Okay, anyone have any more questions? Chloe, Marilyn, Ace, Sheila, Anita, Caitlin, Kay. Then if not, then I hope you learned something, or at least you managed to revise something about electrochemistry. Then I'll see you around lah. Okay? Can? If not, then I think I'll be signing off. Anyone have any more questions? Okay, then I guess I'll sign off. If you still have any more questions, I'll stay back about 2 minutes. I'll sign off at 9:50. Okay, yes, Sheila. Okay, bye. Mhm. Julie, Marilyn, all okay? If Marilyn, you okay, Tips to Okay, if you're genuinely looking for tuition, if you're interested, I have a class at Bishan on Tuesday from 7:30 to 9:30 lah. Like what I shared with Chloe, you can maybe consider doing it online if Bishan is too far from you, lor. If not, alternatively, you can also consider maybe other tutors. So all the information can be found on the Overmark website lah. Okay. You got any more questions not? You okay not? You seem pretty lost at the start, so I hope you managed to catch up, Okay, if not, then I'm gonna sign off. Bye, guys. Okay, ciao. Bye.